Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 1 for this week. And again, as I mentioned in the daily weather update, a little bit unorthodox today. Had to find a coffee shop with Wi-Fi on my way back from Raleigh to Myrtle Beach, and I didn't think they'd like me recording this in the coffee shop, and so I did the work in the coffee shop, and now I'm recording it in the car. So, excuse me. So the bonus weather video today, I'm going to take myself back. Excuse me, geez, old tickle. Take myself back about 40 years, and there was a very famous meteorology professor that was at the University of Oklahoma for a long time, and then he finished up his career at NC State, passed away many years ago, but he used to come to the local chapter of the American Meteorological Society meetings, and he would often challenge me on certain things that I said on the air way back then. And every interaction we had, I always learned something that I could take away from it. And so I'm going to share one of those with you today. So back in the day, and I think there are still some people that do this, unfortunately, but they refer to an upper air disturbance as a center of energy or a maximum of energy. And this professor, Dr. Walt Saucier, challenged me when he heard me using that term and made it very clear to me, and I'm going to make it very clear to you, that nothing could be farther from the truth. So let's go on ahead here. So the question is an upper air wave a center or the center of energy with a given system? Well, let's talk about two types of energy, kinetic energy and potential energy. Well, kinetic energy has to do with movement. And so the equation for that is the mass of an object times the velocity squared divided by 2. Okay, so that's how you define kinetic energy mathematically. Now, let's go back in time, and I guess these things are coming back now. Like, people are getting turntables with records, and I thought that was going to be a dead commodity, but it seems like some of it is coming back. But anyways, let's pretend that we have a record player, and there's a record on the turntable, and you see the little black dot there in the middle indicating where the little hole in the record is that you put it on the turntable, and then you turn the thing on, and it rotates, and you hear sound. But that's not important now. But anyways, notice as the record rotates that there's plenty of movement out on the outer edges, but at that black dot, there's absolutely no movement at all. And that is the point of rotation, okay? So the velocity is 0, and so the velocity squared is 0, and so the kinetic energy is 0 at that particular point. So it's certainly not a maximum of kinetic energy. In fact, it's actually a minimum of kinetic energy, and you can't get much more minimum than 0. Now, let's take a look at something called potential energy. Now, basically, the equation for this is the mass times the gravitational constant, which is the rate at which objects accelerate as they move toward the Earth, times the height. So your potential energy increases as you go up in the atmosphere, okay? And so like a plane flying at 30,000 feet has a lot of potential energy, and then basically some of that potential energy, or all of it, is converted to kinetic energy as it comes down and makes a landing, and once it makes a landing, then it has no potential energy at all. Now that's when you're near sea level. If I'm not mistaken, that if you're up in the mountains, then you're always going to have some potential energy because of the elevation. Okay, so that's the equation. And all upper air charts, we show 500 millibar charts all the time. All upper air charts show what we call geopotential height. And I talk about the fact that, what we're doing is looking at lines that show you equal amounts of height that you have to go up in order to reach a certain pressure. And so these are like isobars in the upper atmosphere. And the geopotential height is almost the same as the actual height. It's barely worth the mention in terms of any difference. So the green area there I'm going to denote as the ground, and now I'm going to put some surfaces up here, and they could be maybe 400 millibars, 500 millibars, and 600 millibars from top to bottom. But notice that they all are closer to the ground in the middle there. And so that is a minimum of geopotential height, because that pressure surface is closest to the ground at that particular point where those surfaces are dipping. It's almost like a topographical map where you've got mountains on either side and you've got a valley in the middle. And so the geopotential height is at a minimum there in the middle. So it's not a maximum of potential energy, it is a minimum of potential energy. So let's sum all of this up. An upper air wave has no kinetic energy at the point of rotation, okay? An upper air wave has a minimum of potential energy at its axis. So an upper air wave is anything but a center or maximum of energy. So if you ever hear somebody say that, then drop them a note and pass this explanation along. It's better to describe it as a center of rotation. And I say thanks Dr. Walter Saucier, because he was the professor that finished his career at NC State and, again, would have some healthy discussions with me back in my very, very early days. And, you know, this is one thing that I always, and I had a great relationship, still do, just not as constant, with the meteorology department at NC State. And I always told the professors that I knew over there that if they ever heard me say something on the air that was not scientifically correct or valid, to not sit around the water cooler and discuss it amongst themselves, but to call me or email me or text me or whatever and let me know, because I have always felt like broadcast meteorologists, in a sense, are representing the science of meteorology. And at least for me, and I think for a good many other people, we take that responsibility very seriously and want to make sure that we are representing the science as it should be represented. So even though at times, back in those early days, I would see him walking up to me, I was sitting there going, oh no, here we go again. He's going to find something else wrong with me. But I learned something from every single one of those interactions. And I think tomorrow on the next bonus weather video, I'm going to share another one of those things that Dr. Saucier shared with me oh so many years ago. And I'll just leave it a mystery as to what that's about. All right. So that's bonus weather video number 1 for this week. Hope you have a wonderful Tuesday evening. Next bonus video and next daily weather update coming up tomorrow. Y'all take care, folks. We'll talk to you soon.